bear with me since we have no projector. I want to do an example. Did we do an example yesterday that was like -2 is less than 2x plus 3 is less than or equal to 15?
Yeah.
Okay. So I want to go down to example 2 here, which is going to look like this. It's going to be 2x minus 7 is less than -11.
Math don't stop.
Or 6x plus 4 greater than or equal to 4. Okay.
What is that? What is that? What was that?
Okay, so that is an or statement, okay? Yesterday we wrote down that an or statement ultimately means our solutions only need to satisfy one of the two conditions, right? Okay. And that's really, it's going to work its way out that way. It's not like we got to choose that we only want it to satisfy these or this condition or this inequality. Our solutions, when we get done and we write them out, picking out any one of those solutions is either going to satisfy that one or that one. It won't satisfy both of them. Is that okay? At least in this one, it won't satisfy both of them. All right, so we solve these. We just solve them normal, like normal inequalities. Okay, so I'll add 7 to both sides here.
Stop.
2x less than -4, right?
Again.
So now we'll have x is less than -2, right? Okay. So solve those. So you solve that inequality. Now I'm going to come over here. I'm going to solve this one the same way. Subtract 4. 6x is less than or equal to 0. X is greater than or equal to 0, correct? Okay. Now, in each one of these, we should have the word or. Okay. We should have kept doing that or throughout the whole thing, but it doesn't matter until at the end you make sure you have this or this. Okay. And then we can write our solutions. And we write these. I'm going to put a graph down. At some point, guys, we're going to pass over the graph, and we won't show it every single time because it's too time consuming. That's the purpose of this interval notation is efficiency and concisely showing all our solutions just real quick. Okay, a graph is not that. Okay, a graph is cumbersome, it takes time, that kind of stuff. But if we can write the graph, it's going to help us make sure we get the right interval solution written down first. So x is less than -2, so I find -2. Okay, and x has to be less than that. So what kind of notation do I use? Do I use a parenthesis or a bracket? Parenthesis. And I'm going to less than -2 is that way, right? Okay. Then I go find 0. 0 is there. It's greater than or equal to. So what kind of notation? Parenthesis or bracket? Bracket. And greater than would be that way, right? Okay. If you're a person that prefers open dot to closed dot, it's going to look like that. Okay. Now all I have to do is we talked about yesterday. If I take a wall and I start moving that wall through my graph, I'm going to write down the values that my wall is intersecting, right? Okay. So what is that first value that my wall intersects over here on this side of the graph? -infinity. So we write that down. Okay. And as I work through my graph, okay, there's going to be a situation where I stop intersecting things, right? Right there, I'm not intersecting anything anymore, right? Okay. What was that last number that I came across that I was intersecting? -2. Now, here's my question. Was I really intersecting at -2? No, I was intersecting at -2.0000, infinite number of zeros and a 1, right? But I can't write that, so I have to write -2. And the parenthesis tells me you get up, you put your toes on -2, but you can never touch -2, okay? From the left-hand side. Now when I write my answers, these should not be in there, okay? Because those values between -2 and 0, they don't satisfy either of those. Choose like a number like -1. Plug -1 in here. You get -2 minus 7 is -9. Is -9 less than -11? No, it's greater. Plug -1 in here. -6 plus 4 is -2, right? Is -2 greater than or equal to 4? No, okay? So you see solutions that are in this gap here, or values that are in this gap, are not solutions to either of those inequalities. But I get to 0, and 0 starts being a solution for these. So 0 is that first value in this interval that I see. What would be the last one? Infinity. Infinity gets a parenthesis. What's 0 get?
Bracket.
A bracket. Okay? And what we need to do is tell everybody that these are solutions. These will work, okay, for one of those inequalities. These will also work for one of those inequalities. So the way we say we're going to group all these together is we put a union. Okay? That union symbol means all things that are listed in both intervals are solutions. Okay? The way I think about this, guys, is I went from negative infinity to infinity, right? If I start at this one, get to that one, negative infinity, infinity. But in the middle somewhere, we had to kick some values out. We had to kick all the values from, including -2, all the way up to, 0.9999999999999 and forever, right? We kick those out, and that's the way that we show and represent that we've kicked those out, all right? Or they're not going to be solutions. So that's an or statement. We'll do another one like that. We've got 3x minus 5 is less than -10. Or 5x plus 2 is greater than 5. Tomorrow we'll work on absolute value inequalities. And so you'll have an absolute value statement and a less than or greater than sign and then some number. In order to solve that, we first need to transform that absolute value inequality into something like this. Okay? So this stuff here is kind of a precursor to the information that we're due tomorrow. Okay? So if we don't pick up on this and we struggle with this, obviously then the absolute value inequality is going to be something to struggle with as well. All right, so solving those, okay? Again, the algebra component, I don't think, guys, is going to be an issue for you. Okay? Add 5 to both sides. X is less than -5/3, right? Okay? If you've done any of the homework that I've opened up, again, I don't think any of the algebra is going to be a problem. You got to the last couple questions in that homework. The algebra is not a problem. It's then interpreting what I'm supposed to do with that algebra and write my answers. Okay? And hopefully we have some time to talk about those couple questions at the end of here. But I get that, right? You guys all okay with that algebra? Okay? Now it's just interpreting that and writing that in a acceptable manner. So we're going to take our number line. Okay, I'm going to deal with this one first. So find -5/3. Okay, now let's put down. And we'll find this one here, 3/5, right? If I go x is less than -5/3, what kind of notation do I use? Parenthesis or bracket? Parenthesis. And we'll shade that way, right? X is greater than 3/5. Parenthesis. Shade that way, correct? Okay, so writing my interval notation, we start at -infinity. I get up to -5/3. And then I'm going to union. So I skip this union, basically says there are some values that we're going to skip over on our number line. The next value that I see as a solution is 3/5. And the last one will be infinity. And those are all the solutions that satisfy this or condition. Okay? These obviously will satisfy that inequality. These will satisfy that one. None of these satisfy that one though, right? None of these will work for that one. Okay? That's not always the case with or. Sometimes there will be, some from this set that satisfy that, and there will be some from this set that satisfy that. And when that happens, we have a really nice special case, and our solutions are really convenient. I think that's actually going to happen in the next example. See, we have questions so far. We're good? We've seen some of this, right? We've done this. Making sure that we're all comfortable with this, because as we move on through the year, it's going to be commonplace to deal with inequalities. It'll be commonplace to deal with this interval notation, and we won't have time to go back and say, okay, remember how we do interval notation and how we do linear inequalities? It'll just be something that we We just do. It'll be instinct. Okay. All right. So let's do. I guess this one's an and statement. Let's go 2x, or 2 times x plus 1 is less than or equal to 5. And I don't want to do and. I want to do or. Let's do or. Maybe we'll come back and do both of these. Or 2x plus 1 is greater than negative 3. Just take a minute to solve those. Okay, solve both those. Couple different ways you can do that. I think most people probably distribute the 2, don't they? Could I divide both sides by 2 as well? Yeah, so x plus 1 is less than or equal to 5 halves. And then I subtracted 2 halves from both sides, which is subtracting 1. Let's be 3 halves. Maybe over here I'll distribute this one. 2x plus 2 is greater than negative 3. 2x is greater than negative 5 halves. I'm sorry, 5. Then it's 5 halves. Okay, so you get x is less than or equal to 3 halves and x is greater than negative 5 halves. All right. And remember, these are or. Okay, so when I graph my inequalities here, now look at this one. X is less than or equal to 3 halves. Find 3 halves on my number line. Less than or equal to would be those there, right? Okay. Find negative 5 halves on my number line. So maybe that's over here. Greater than. So it's going to be that stuff. Okay. Now, if you're neglecting the fact that we've got an or statement here, and you're just saying, I'm going to go through the procedures that Mr. Fay told us, and we write down that inequality there. Looking at that's the black graph, right? And you say, okay, well, that goes from negative infinity. The black graph is negative infinity up to 3 halves, and we include 3 halves, right? And then you might say, okay, well, then I'm going to look at the red one, and the red one goes from negative 5 halves, and it's a parenthesis. It goes from negative 5 halves up to infinity, right? And then you're going to say, well, I union them. And you are absolutely correct. You have shown all your solutions, okay? But there's overlap in those solutions, isn't there? Okay? Because the graphs overlap, and it's a little bit easier to see here because the graphs overlap, because we have the graph here. But a number like 0 is in this list right here, because that's what this is. This is a list of numbers, right? 0's in that list, and it's in that one. That's redundant. We don't need that. We don't want that, okay? So when I look at this and I compare it to the other ones we've seen, remember the other ones, we use this union tool to basically kick values out, right? Kick values out that we don't want to be solutions. Are there, if I look through my number lines here, will I ever have that wall that I slide through here? Will that ever not be intersecting some of our solutions? It's always intersecting either the black or the red, right? So if that's always happening, what's another way of saying our solutions? A better way of saying our solutions. From what number to what number? Negative infinity to positive infinity. That's how we want to write it. That's how WebAssign is going to ask you, okay? That's what I'll be looking for on tests and quizzes. If you write this on a test or a quiz, or write out in words all real numbers, that's fine as well. Negative infinity to positive infinity, that interval notation is your number line, okay? Penny?
So like when you do the second interval notation, you just take the first number of the first bracket area, and then you take the last number of the second one. Is that how you do it?
Yes, because those between 3 halves and negative 5 halves, we've got overlap, right?
Yeah.
Because these are, that one is more, should be to the left of that one if on the number line regardless, right? So because of that nature, we can see that there's overlap, so I just put that one down and then that last one, yes. Here, and I don't have an equation that would present this, but, or inequalities that would present this right now. Just going off my top of my head, there are some things though that you might see down the road that has something like this, where I've got We'll just use like 3, and I'll go 6 here. And we've got solutions like this. Maybe we got something like that. And let's say it's an OR statement again. Okay? If it's an OR statement, okay, write this one down here. It'd be 3 to infinity, right? Write this one down here. It'd be 6 to infinity, correct? But OR means we want all solutions, right? So a lot of people are going to say, well, we do 3 to infinity, and then we union 6 to infinity. Well, they both go off to infinity, so like 12 is in this list and it's in that list, right? 13 is in that list and in that list. So we're repeating some of our solutions. We don't want to do that. What would be the first? Yeah, we want 3 is that first value we come across graphically that we need to write down. And the last one come across is infinity. So if this was an OR statement, okay, this is how we would write that solution for that graph. Okay? If it's an AND statement, if it was an AND statement, where do we start? We would start at 6, right? Because AND means it's got to be a solution for this graph and that graph. It's got to be a point on both of them at the same time. Okay? What can I do for you?
I can wait if you're...
Yeah, you're going to have to.
Okay.
All right. What time is the period over, guys?
56.
56? You're going to wait like for 16 minutes.
Okay.
All right.
Sorry, listen to the library.
For who? The librarian?
Are we just gonna follow the regular
Maybe.
schedule and leave at 11:30?
So does anybody have questions on that? Okay. Let's say, let's see here. There's a couple on the end of your assignment, and hopefully maybe we'll have enough time to do a couple of these examples. But those are all linear inequalities. Okay. Everything we've done so far is a linear inequality or compound linear inequality. We might see some things like this throughout the year, and I say might, we will. Okay, we will definitely see these. And this system or this approach here that we're going to use is necessary inside those things, because there's a lot of different areas that we have to use what we call a sign chart. They're the same, whether it's a rational inequality or in this case it's a polynomial inequality. Okay, you do not address these the same way that you would address like a quadratic equation. Okay, there's parts that are similar, but the overall approach is a little bit different. This is what we're looking at here, guys. If I look at x plus 4 times x minus 2, if you think about what that came from a quadratic inequality, right? Something like this would have looked like x squared plus 4x minus 2x, so plus 2x minus 8 is greater than 0, right? Or any version of that, or maybe the 8 was on the other side. But whatever it looks like, if it's quadratic, the first thing you have to do is get all your terms on one side, get 0 left on the other side. Okay, have the inequality. Then you need to factor. Okay, so that's where it's similar to the quadratic equation. Okay, if this was equal to 0, we would set this off ax squared plus bx plus c equals 0. We would factor that. Okay, but after we factor it, this is where it kind of gets a little bit different. Because what does greater than 0 mean? Positive numbers, okay? So we're looking for positive numbers. That's what that means. Greater than 0 means positive numbers. So this is a factor, right? This is some number. When x is some value, this is one concrete number. This is another concrete number, okay? Sometimes this will be positive, this factor will be positive, and this one will be positive as well. What's a positive times a positive? Positive, greater than 0. So those would be solutions, right? But there's also situations where this would be negative. You know, if x was negative 10, is that negative? If x is negative 10 here, is that negative? What's a negative times a negative? A positive. So x being negative 10 needs to be one of our solutions, okay? But if x is 0, that's a positive, and that's a negative, right? That product would give me a negative, not satisfying this condition. So what we need to be able to do is create a system, a procedure that quickly identifies all the numbers that are going to provide me a product that turns out to be positive. Okay? So the process of doing this is First, treat it, like I said, like a quadratic equation, because we talked about yesterday, if we can find out where it's equal to 0, then we know where it's unequal to 0. Does that make sense? Okay. So that's why we had to factor it first, because we know that that thing should be equal to 0 at -4 and +2, correct? So just make a quick number line, okay? Those are the places that are equal. So in between -4 and 2, it's going to be unequal. It might be positive or it might be negative. To the right of 2, it's going to be unequal. It might be positive or it might be negative. To the left of -4, it's going to be unequal. It might be positive or negative. We have to decipher that, okay? I do know, though, because that was a greater than sign, but I'll never be interested in being equal to 0, right? And then this overall approach. So I'm going to put open dots there, put parentheses if you want. But this is the approach, okay? I'm going to do that, and this is just an organization tool. This is called a sign chart, okay? It's just a tool for us to figure out what this side is going to be in regards to values that we choose, okay? You write down your factors. X minus 4, sorry, it's x plus 4, x minus 2, and then we write our total,
Man, I can't see.
okay? So, we've got x plus 4, x minus 2, we've got our total. And our total, you can write this several different ways. If you want to write just the word total, if you want to write the word product, or if you want to actually write down the x plus 4 and the x minus 2 part, okay? But that's what we're doing, okay? And you got 3 kind of categories here that we're going to look at. If I look at my number line, okay, -4 and 2 are kind of my cutoff points, okay? Those are going to decipher, those are going to decide my values that I plug in, okay? So look over here to these values on the left of -4. Give me a number that's to the left of -4. -5, okay. -5 will work, and it's perfectly fine. If I plug -5 in right here, what do you get? What do I get if I plug -5 in right here? -1. What do you get if you plug in -5 right here? -7. Okay. What do you get when you multiply -1 and -7? You get +7. Okay. Okay. So I think Fami gave us -5, right? Somebody give me another number over here.
7.
Okay. -7. What's -7 plus 4? -3. What's -7 minus 2? -9. When I multiply those, what do I get? 27. What's the positive though, right? Any number that I choose over there is going to give me a negative and a negative. Their product is always going to be a positive, right? So I don't ultimately care about the numbers. I care about the fact that whatever I chose over here was a negative, then a negative, and their product then is a positive. Does that make sense?
You had a guess, but you
No.
didn't. That's creepy.
Is that okay with everybody?
Yeah.
All right, so let's go to the middle section here. What's a number in that middle section that would be really good to plug in? 0. If I plug 0 in here, what do I get? 4. But it's positive. I care about the positive. Okay? If I plug 0 in here, what do I get? -2. But I care about the negative. Because any number in that interval, like 1 is going to be +5 and it's going to give me -1, right? The product of any two numbers inside that interval, when plugged into these factors, is going to give me a negative final result, right? Or a negative product. Come over here to 2.
You got a text message.
Okay, to the right of 2, okay, it'd be 3 or 4 or 5, right? Okay, so 5 plus 4 would be 9, which is positive. 5 minus 2 would be 3, which is positive. So what's a positive times a positive? Positive. Guys, I know there's things that are going on that are not conducive to learning, but we're going to learn, all right? So worrying about whether I got text messages, worrying about somebody coming in the classroom, worrying about the fact that maybe it's dark in here is not a big concern right now, okay? Focus on the math. If we've got this set up, this is our final result, right? That's our final result. we need to compare these to what we were looking for. We were looking for positives, right? We were looking for numbers that are greater than 0. That's greater than 0. Positive number right here would be greater than 0, right? Positive number right here would be greater than 0, right? So these numbers here, those values there, this is just a number line up here, okay? And those values there represent, when I plug into here, I will get a positive result. Try a number, try -5. -5 gives me -1. -7. -1 times -7 is 7. Is 7 greater than 0? Yeah. Try a number like 0 here. Why didn't we choose 0? Because when I plug 0 here, you get 4 times -2 is -8. Is -8 greater than 0? No. Okay? So these values that I've shaded are representing the values that satisfy this inequality. Okay? So then we got to put that in interval notation. So number line, what's the first number I would come across over here on the left? Negative infinity. And what would be the last number I come across? -4. Okay? Now, this is the reason I put that open dot there at the beginning. I always want to pay attention to that. It was greater than, so I put an open dot there. So I remind myself that -4, when I plug -4 in, it gives me 0 times -6. That gives me 0, right? Is 0 greater than 0? No. Okay? So that's why I had to put that open dot there, so I reminded myself in my interval notation, that's a parenthesis. Now I come here, so I'm going to skip these values, right? Right down to last value is infinity, but what do I do to connect those? I union them, okay? And that tells me that those are all my solutions, okay? It goes from negative infinity to positive infinity, but somewhere in the middle, we had to boot some values out. We had to go -4 all the way up to 2 and take all that set of values out. Is that okay? All right, let's do...
There's 5 minutes left.
Let's do, all right, so it doesn't matter, guys, what the nonlinear inequality looks like to you right now. The ones that I provide you are going to be quadratic. So they could give you something like this, right? So this is one that people struggle on, okay? But that's a factor. It's just where x is 0, right? So I'm not going to do all of this with you, but my number line would be 0 and -3. And then we put x over here, put x plus 3 over here, and then we put our total. Is that okay? And you would go through choosing values out of those intervals. Positive, positive, negative, negative, positive, negative, that type of thing, and see what the total looks like. You'll also see maybe at some point something that looks like this, where we've got x squared plus 8x is greater than -24. Okay, it's a nonlinear inequality. Nonlinear because that power of 2. Well, that means it's quadratic inequality, polynomial inequality. We get that side to be 0, and then we factor this side, and it gets down to something that looks like this. Is that okay?
So you always make it equal to 0?
Yeah.
Okay.
And it's kind of hard, because I mess this phrasing up as well. I make this side 0. I don't want to say I make it equal to 0, but I make the side equal to 0. Yeah. Here's one that is, I think, the last 3 questions on your homework.
That clock doesn't work. It's 9:52.
I know.